All right, we started up yesterday with going back over our right triangle trig, going over our sine, cosine, tangent, and how we do some of the calculating on that. Now we're going to put it to use with some applications, with some story problems. And as it mentions up at the top, we want to read through the problem carefully to see where all these values are going to go and what this should look like. Draw and label something that looks like a triangle, because all these will form that. Set up a quick little equation and then solve it. So our first example, we're going to deal with a boy who's flying a kite lets out 300 feet of string, which makes an angle of 52 degrees with the ground. Assuming that the string is stretched taut, which means it's tight, find the nearest foot how high the kite is above the ground. Okay, so all of these are going to form a triangle. If you want to draw kites and all this other stuff, you can, but I like to keep it simple. So this kite's flying up here somewhere, and it's got 300 feet of string. So from this boy to where my kite is 300 feet of string, and it makes an angle of 52 degrees with the ground. So that kind of tells me where the 52 is going to be. All of these are right triangles, we know that part. Assuming that the string is stretched taut, find the nearest foot how high the kite is off the ground. And whenever we're looking for height, that's a straight up measurement. Okay, so whenever it says something like how high above the ground or something, that's going to be our vertical, or our line that makes the 90-degree angle here. So I've got all my information now. I got my angle to base things off of. So now I got to go back and I got to go, okay, which sides do I have? Well, if this is my angle, this is my side that's opposite, so that's where my x is at. And I also had the value across from my right angle, which is my hypotenuse. So which of my three trig functions am I going to be using with this? Well, if we remember back to yesterday, we can remember which sides go with which by remembering this SOHCAHTOA. So if I have O and H, I have the trig function that starts with S, or I'm dealing with sine. So sine of 52 is opposite over hypotenuse. And we also talked yesterday about a pattern that develops with solving these. Now, could I set it up as a proportion and solve it? Sure. But we also had mentioned if our x, if our variable is on the top, okay, if our value here is on the bottom, it's just going to end up being multiply. Now, as I also mentioned yesterday, when we go to do this, we got to be careful. We always want to check, especially if your calculator is not yours, that you go to mode, because this is not good. Okay, we're not doing radians right now. We're doing degrees. So always check your calculator, again, mode, and then degree to make sure you're doing this right. Because if you have it in radian mode, you're going to get different answers. So I can get out of there now. 300 times the sine of 52. And it says to the nearest foot. So in this case, that would be 236, because 0.4 will not round up. And that's how these set up. So the expressions aren't that quick. It's more drawing the picture and just getting used to what you're going to be trying to solve. Okay, next one. Find the nearest degree. The angle at which the sun's rays make with the ground when a flagpole 40 feet high casts a shadow 30 feet long. Okay. So a flagpole that's 40 feet high, flagpoles are, again, vertical, casts a shadow. The shadow is on the ground. I mean, think about it when you stand there and you're out in the sun. Okay? You're not seeing the 3D from like the top of your head down. You're seeing that shadow along the ground. So the 30 is going to go down here. And then find the nearest degree, the angle which the sun rays make with the ground. Okay? Not up where the sun's at, but down here at the ground. And that takes some getting used to, too. So you're like, okay, so what have I got here? I got the opposite, and I have the, oh boy, adjacent. Okay, so opposite and adjacent, I'm going to go with the one that starts with T, so tangent. So the tangent, and we talked about when I'm looking for an angle, that's going to be a little different. I put that little -1 there as my reminder when I'm looking for an angle, and we'll talk about that again in a second. Adjacent over opposite. Because again, when I'm looking for an angle, it's always going to be second, and then whatever my trig function is, and then plug in my fraction. So when I go to do this particular one, get my calculator out of the way here. So I'm going to do second tangent. There's a little -1. That's how it reminds me, oh yeah, I got to do the second thing, otherwise that doesn't show up. And then I do adjacent divided by, oops, no, Harty, this is not cosine. Opposite divided by adjacent. And again, we're going to the nearest degree. So that'd be 53 degrees. Times that with that guy. So you see, it's kind of playing with it a bit and also seeing if your answers make a little bit of sense as we go. So I get down to example 3. Okay, we've got an airplane rising at an angle of 14 degrees with the ground. Now, I don't always worry about making my pictures like perfectly to scale here. Kind of can drive you crazy otherwise. So again, it says with the ground, so my 14 degrees, be along here along the base. Find the nearest foot, the distance it has flown when it has covered a horizontal distance of 1,500 feet. Okay, horizontal just meaning it's a straight line going side to side. Well, where does that occur? That occurs down here. So what am I trying to find? The distance it has flown. So it takes off, and there it's flying. So that's what I'm looking for. It doesn't say how high is it off the ground. It says how far is it flown. So I've got my information again to work with. I look and I go, okay, what sides do I have this time? Well, opposite would be over here. It doesn't give me anything. I don't know what that is. This would be adjacent. And again, the side opposite my right angle, my longest side, is going to be my hypotenuse. So I look at that and I go, okay, well, let's see. I got adjacent and hypotenuse. Let me come back down here for a minute. Adjacent and hypotenuse, cosine. Okay. So the cosine of 14 degrees is adjacent over hypotenuse. And we said before, when our x values in the denominator, when we're dividing by the x, that means we're going to be dividing by this. Now, I'll kind of do a rewind to yesterday here to let you see why that is. If I turn this into a proportion, I'd cross multiply. 1 times 1,500 is 1,500. But then since I'm trying to solve for x, I'd have to divide by my trig function. And that's what I was saying and what I said in the notes yesterday. If x is on the bottom, we're going to divide by this. If x is on top, we're going to multiply by this when we get to the end. It's just a shortcut, but I can still get to my answer this way. It's not a big deal. Okay, no second this time. Not an angle that we're looking for. So 1,500 divided by the cosine of 14 degrees. What are we going to here? The nearest foot, okay? So 1,546 feet would be the distance that that plane will have flown so far, which is sensible because the hypotenuse has to be longer than one of my other sides, so it better be better than 1,500. And finally, okay, at the top of a 40-foot ladder, let's kind of do this one as we go here. Top of a 40-foot ladder, so when I put up a ladder, I'm leaning it against a wall, okay, it's not laying on the ground, reaches the wall at a point of 36 feet from the ground, which means my wall from the ground to where my ladder touches is 36 feet. Find the nearest degree, the angle which the ladder makes with the wall. Ladder, wall, there's my angle. Okay, so little words like the ground, which tells me here, the wall that tells me up here. I gotta watch for those things and make sure I get that situated. Okay, so I've got that up here. Ooh, I'm looking for an angle. What's that mean? Yeah, we're gonna be doing the second in a trig function, but which trig function is the question? Let's see. opposite. Side that's connected to my angle is adjacent. Longest side, side opposite my right angle is hypotenuse. So we got adjacent and hypotenuse. Which trig function are we using this time? You got it, cosine, just like we had here. So cosine, reminder that I'm looking for an angle, is 36 over 40. So go ahead, second cosine, 36 divided by 40, boom. And we're going to the nearest degree. So it looks like it, whoa, not 260, 26 degrees. Okay, so you've got a worksheet now that has some problems that are similar. Again, draw the triangle, label your sides, and kind of see as you're going along. Work with each other, work this out. We'll see some more of these going forward, but we're going to start dealing with special right triangles tomorrow.